Hello everybody. I promised to give you good afternoon. Yeah. So I promised to make this video. This will be the additional video for this week. So again, all you have to do is to watch the video and answer the question in the quiz. Okay? Once again, I'm going to go over what we've learned in class. Okay? And I want you to be attentive. Okay? It's not hard. So we went over some of this concept, and I told you this is a system unit. System unit is like a casing, like a container. This is too deep. The thickness is too deep. Okay, let me see. Well, so that's system unit. So, like I say, protective case for all the electronics. Okay, so you need to know the difference between system unit and a motherboard. Okay, so this is a system unit for laptops, while this part is what? A VDU, visual display unit. For desktop, this is the VDU, visual display unit. And for your phone, of course, this is your system unit. And for this device, this is the system unit, and so on and so forth. And when it comes to components of the PC, now you've seen many things this week. One of the videos on how you can assemble the PC. This one is showing you more detail. Okay? So now, this is the motherboard we talk about in class. The motherboard is like a platform or a plate that contains all the circuitry. It's not the same as system unit. Okay? It's not. And the monitor is also called visual display unit. You know the power supply by now, and you know the DVD RAM. So this is the RAM card. So the RAM card, you can fit it into one of these, I think. And you have a sound card, and you have the video graphic adapter. You have the hard disk. Look at the hard disk. Remember, we talked about hard disk today, which is the memory, right? The ROM inside your PC. So the performance, how expensive this machine is, depend on the capacity of this hard disk. All right. So look at what you have here. VGA again means what? Video graphic adapter. Or adapter, So when you look at it, typically a computer system, you will see hardware and software. Okay? In the hardware, you have the central processing unit. You have the main memory. The main memory. Now, the reason why RAM is called main memory is this. You see, RAM, which is random access memory, is the main memory. I will tell you the reason why it is called main memory. Now, when you load an application, maybe Microsoft Excel or Microsoft PowerPoint, okay, when you load it, so RAM is holding that application when it is loaded. And when you are typing anything on it, before saving it, everything stays in RAM. So RAM is the main memory. It's actually the main memory because it is directly connected with your CPU and it's very fast. Okay, but if you don't save what you have in RAM, when the power is lost, you lose everything. So RAM again is a what? Volatile memory. It's a main memory and it's volatile and it's faster than ROM. So you have secondary storage. You've seen different input and output devices. And when it comes to software, because a computer system is actually made up of two things, hardware and software. When it comes to software, you have two types of software: system software, like all the OS, Linux, Windows, Mac OS. Those are some like device drivers. They are system programs. And you have application programs like all your game program, Microsoft Office, web browser. All other ones are just application programs. So software is of two types: system programs and application programs. Now, the CPU, like I said before, this is a typical CPU, is the brain of the computer and is the most expensive piece of hardware. And what does it do? It carries out arithmetic and logical operation. Arithmetic and logical operations. What do you mean logical? Remember I told you in class, uppercase alphabet A is represented as number 65. And this number 65 is converted to binary. I can't remember maybe 01000011, something like this. I can't remember. You have to make it 8. So I'm not sure, but suppose when you convert 65 to binary, this is what you have. Now, this is the way computer stores information. And internally, actually, computer manipulates, carries out arithmetic operation involving bits. The CPU works, okay, by carrying out arithmetic operation involving bits manipulation. Bits manipulation. Okay. All right. So let me clean that. So once again, it carries out what? Arithmetic and logical operations. CPU is a complex integrated circuit. Look at that, consisting of millions of electronic parts, and is primarily responsible for converting inputs into meaningful outputs. So it enables data to travel in and out. Now, data travels in and out of the CPU through embedded wires, which we call a what? A bus, which you call bus. Not like school bus, right? This is a data bus. So information moves in and out of the PC through a bus. So look at the CPU inside now look at laptop. So if you open the laptop, the CPU is located around here, like the middle. So you have CPUs inside every laptop. You have CPU on phones. See CPU on smartphones. Everything has got CPU, right? Smart machines have CPU. And once again, CPU is a complex integrated circuit consisting of millions of electronic parts. And all those electronic parts, CPU, every other ones, they found everything. You put them on motherboard. Then you cover them with what? System unit, the casing. Now, what is random access memory? Random access memory is called is the main memory, and it's directly, look at that, it's directly connected with the CPU. Directly connected with the CPU. The programs must be loaded into main memory before they can be executed. So when you open a file, Microsoft Word, to type So Microsoft Word is an application. So you must load it into main memory, which is the RAM, and it's volatile. So data must be brought into main memory before it can be manipulated. There is no other way. There is no shortcut. So when the computer power is turned off, everything in the main memory is what? Is lost. Everything in the RAM is lost. And main memory is an ordered sequence of memory cells. So the main memory is like this. It's a collection of cells. Cells. Look at that. And this cell can hold data and or instructions. For instance, if I put my name here, Ezi, so the memory for Y is separate for the memory for Z, right? And each of these cells, they have an address, and we call that memory address. Memory address. And memory addresses are expressed as hexadecimal numbers. Once again, hexadecimal is base 16. Base 16. Base 16. I will show you more about that later on, okay? So each cell has a unique address called memory address. Okay, each cell can contain either what? Instruction or data. So in a memory cell, when you open it up, if you are able to see it, you can either see what? Data or instruction inside the cell. Okay? Now look at the CPU, look at the main memory. You can see that the main memory is directly connected to CPU. The hard drive, the secondary storage, which is the hard drive, is actually away from, a little bit away from the CPU. So when you click an application on your system like Microsoft Word, it is loaded into main memory. Then when you press Ctrl S, it's transferred from main memory into the RAM. This is what? ROM. This is RAM. And this is what? ROM. If you don't save anything in your RAM, you lose it. But if you press Ctrl S to save it, it comes there permanently, which is your hard drive. Once again, each of the cells, main memory, they are tiny cells built together, and each of these cells has got what? A location address. Just like your house address, but this kind of house address is not a denary number system. You know, denary is base 10, right? From 0 to 9. Base binary is 0 and 1. Octa is 0 to 7. Base 4 is 0 to 3. And base 16 is 0 to F. I will show you that later on, okay? So the processor is the central processing unit. Some of these things we covered them last week, so I will just show you briefly. CPU, and it's carry out operations on the PC. So you have input devices here, main memory, output devices, storage devices. You have the processor. That is the way computers are built. They have to be connected. Okay, they have to be connected. The control units of the CPU. Now, the control unit is part of the CPU. Look at it. The CPU is called Central Processing Unit. It actually contains what? A control unit and an arithmetic logic unit. Okay? So the two of them works together. So the control unit is the component of the CPU that directs and coordinates most of the operations in the computer. So the control unit has a role like a traffic cop, interprets each instruction issued by the program, and initiates appropriate action to carry out instructions. Okay, and there is arithmetic logic unit. This one is a part of CPU. Now, CPU contains two parts: control unit and the arithmetic logic unit. The arithmetic logic unit is actually main guy. I mean, it does all the computation. all the computation, right? All the computation in the system, like subtraction, addition, multiplication, everything are carried out here. And that part, CPU, once again, is the most expensive part. Now, the machine cycle, we've seen this is what? Fetch, decode, execute, store. FDES. Those are the I'm not going to go over it because we have seen this in last week. That's the basic machine cycle, the way your machine works. It fetches instruction, decode, execute, and stores it. Now we move to secondary storage. Secondary storage is any device that stores information permanently. Like your hard disks. I've shown you hard disks in class today. Your flash drives, your CDs, your tapes. And it is called, they are called also read-only memory. Okay? And it's attached to the motherboard. The motherboard is the main circuit board of the computer. You need the motherboard, something like this. This is where you put everything. You put your CPU here, you put your fan, you put your power, everything, your VGA card, your RAM slot, and then that's the motherboard. Then you put everything inside the what? System units as a cover to protect everything inside. Okay? And there is also the concept called CMOS, which is complementary metal oxide semiconductor. Okay, some RAM chips, flash memory chips, and other types of memory uses what is called CMOS. Now, the CMOS uses the battery power to retain information when the power is turned off. Okay, that's very, very good. So when the power is turned off, some of them can still retain some information. CMOS battery, CMOS memory chips, for instance, can keep calendar, date, and time current, even when your computer is turned off. Look at that. So when your computer is turned off, why are you able to keep calendar, date, time, current? That is made possible by what? CMOS or CMOS technology. Okay? Good. So what should I do if my computer's date and time are wrong? You have to set it. You have to reset it. That's the first thing. To do this in Windows, double click the taskbar, and if the computer continues to lose time or display an incorrect date, you may need to replace your what? CMOS battery on the motherboard. That is what all these hardware engineers do. I mean, that's what they do. So even if you try to change the date on your system here, right, the date here, if you try to change it here, see, down here, if you go down here, if you try to change it and it's still not working, you might have to change your CMOS battery. Look at the internal view of a desktop hardware. The one that guy assembled in that video. Look at it. Look at the sound card. Look at the video card. Look at power supply. Look at drive base, processor. Imagine. Look at CPU. Look at the CPU. Look at memory. And motherboard is this. Look at motherboard. This is clearer than what you've seen in the video. So all the circuitry, you fix them on the motherboard. See? This expansion slot for, you can add many cards. You can add a card to enhance your RAM or memory, any other stuff. Okay, and this, I think, CPU, it's kind of here, if I'm not mistaken. Right? This might be CMOS battery, I'm not sure. And this is a fan. Okay? This is a cooling fan. This is a slot for memory, for additional memory, RAM memory. So that's how your motherboard looks like. Now, you put motherboard, you cover the motherboard, everything inside the system unit. Okay? And then you have input devices like keyboard, mouse, secondary storage, monitor. Then you have output devices, monitor, printer, secondary storage. Now, some secondary storage are input devices. They are also output devices. Okay? Yeah. For instance, this can be what? An input device is your flash drive, and it can also be an output device. For instance, you can input data from your flash drive, and you can also write to it. Okay? So some input device, some secondary storage can be, that secondary storage can be used as what? Input and output devices. Some, not all. Because your main memory, I mean not main memory now, the ROM inside your PC is not input, it's for permanent storage, so you cannot use it for output. It's not outside of your system. But if it is outside, like the external hard drive, then that can be used as what? Input device. Because if I have my external hard drive like this, something like this, I can connect my laptop with this and write into it output, or bring data from here into my system, input. Okay? So volatile memory loses its content when the power is turned off. So your RAM is volatile. Non-volatile does not lose its memory. Okay? ROM chip contains BIOS. BIOS means basic input and output setting. I won't write that. Basic input and output setting. So the BIOS performs power on self-test post, which tells the computer components for proper operations. So the BIOS, the BIOS chip, it actually, for this functionality, it does post operation, power on self-test. It tells all the computer components what they do, what they need to do, proper operations. Okay, ROM provides the means of communication between operating system and hardwares. Look at that. ROM provides the means of communication between what? Your OS and hardwares. So computer manufacturers often update instructions on the ROM chip, and those instructions are called firmware. Now the firmware comes with your hardware from the industry. Okay, it's a software too, but that actually comes from the industry. Okay, come naturally from industries when you buy the app, so it's already part of it. Okay. So the firmware is designed, is a company product. They put it as part of what? The native integral part of your equipment that you bought from them. Okay, firmware. So a firmware is a software. Okay. So how a computer might use a virtual memory. Now, virtual memory, you need to know about it. When you run your operating system and other apps on your computer, the OS and each requires certain amount of RAM to function properly. So remember RAM now? But if your computer runs low on RAM, it may need to swipe the content of RAM to and fro. This is your CPU, this is your RAM. So if you run out of RAM, right, you may need to make sure you move some of the data from your RAM into a place on the hard drive. That temporary place is called virtual memory. Virtual memory. So the area of the hard drive temporarily used to store data that cannot fit RAM is called swap. It's called a swap file or paging file. Okay, so there is an area in your hard drive. When you run out of RAM, remember RAM is a main memory and it's volatile. When you run out of RAM, some of the data are moved into the hard drive in a place called subfile or paging file. Okay, see now this is your RAM. You are running out of RAM. Data is moved to this place and then to your what? Hard drive. So still this place is now what is called virtual memory. Virtual memory. So types of RAM. RAMs can be, you have dynamic RAM, you have static RAM, you have magnetoresistive RAM, and you have flash memory. Flash memory. Okay? That's types of RAM. Now, dynamic RAM, that's a volatile one. That's a volatile one. That's a volatile one. That's the one you have. That's the one you have in your system. The main memory is dynamic. You have a static RAM, and you have, So the first two here are volatile, while this one are what? Non-volatile. The flash memory is a non-volatile type of RAM. Flash type of memory that typically is less expensive than some other type of RAM, but can retain its contents in the absence of power. Okay. So you have more images on computer memory. Look at RAM chips. This is where you fit your RAM chips, how you can fit your RAMs. Look at the RAM modules. So this green stuff, you can change it. You can increase the capacity of your RAM by changing this the chip. Okay. And there are what is called expansion slots and adapter cards. So expansion slot is a socket on the motherboard that can hold adapter card. Adapter card is sometimes called expansion card, and it's a circuit board that enhances the function of the computer system. So you want to add for more functionalities to your PC, you do that through what? Expansion slot. We've talked about this in class, okay? And there are different types of adapter cards. You have a DIX controller, FireWire, MIDI. Remember MIDI? Musical Instrument Digital Interface. Musical Instrument Digital Interface. That is used to connect your piano to your laptops. You have a modem. Modem is used to connect your computers, okay, to telephone or cable television lines for your internet service. And the meaning of modem is derived from modulator, demodulator. Now, the reason is because in the olden days, the information travels through these patterns, the old analog telephone lines. But nowadays, the digital system is zeros up, zero, on, off, on, off, on, off. This is the wave font. So a modem that you have at home, convert data from this format into this format and from this one back to this one, or from this one back to this one. Once again, you have data traveling in a wave form like this, and you have data traveling in a digital form, on, off, on, off, on, off, on, off. So you need to convert from this form to this form, and that is made possible through what? The modem. The modem is at the back of your TV at home. Most people have it. Okay. Now, this is a more flash memory card, USB flash, PC cards, and express card models. You have several ones. See, you can buy. We've seen this in class today, okay? So there is no point going over it again. Look at, wow, look at ports and connectors. I like this. I like this. This is going to help you a lot. This is just to add more information to what you already have. A port is a point at which a peripheral a port is the point on your system case at which a peripheral attaches or communicates with the system unit, so that the peripheral can send data or retrieve data from the computer. So look at this port: mouse ports, firewire ports. We've seen that in class. Network ports, speaker port, audio port, video port, parallel port, serial port, FM reception port, cable TV port, several stuff. See, USB ports. So you want to add additional stuff to your system, peripherals. You do that through ports. And then, very, very important, we move to what is called number systems. I told you computers are what? Binary machines. Computers are binary machines. In other words, your computer, your digital devices, they work on base 2 systems. Base 2 systems are made up of numbers using 0 or 1. And 0 represent the internal state of the PC, like voltage off 0, voltage on 1. So zeros and ones. And we've seen that. So you have binary number system, which consists of only digits 0 and 1. You have octa, which is a base 8. This is a base 8 system. Octa is base 8 system. You can consist only of digits from 0 to what? To 7. Decimal system consists of digits from 0 to what? 9. And hexadecimal system consists of digits from what? 0 to what? Alphabet F. So in hexadecimal number system, you start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, you don't say 10. Your 10 is represented as A, 11 as B, C, D, E, F. There is no G. You stop at F. And if you count everything, that is 16. 16 stuff. So the hexadecimal, oh, that's my friend. I will call back. Hexadecimal consists of what? And your computer memory address are actually expressed as hexadecimal system. Another uses of hexadecimal system is your memory DOM, or the HTML web design, HTML color pickers, HTML color pickers. I will show you some of them. Now look at that. Look at the symbol. So how do you express decimal? Decimal is called, actually I told you in class, you can call decimal, you can call it denary. Denary system, and binary is base 2, right? So look at decimal, the one we are all familiar with from high school, elementary school. All the natural number system consists of zeros. All the numbers that you have, your social number, everything, you make them from this 10 combination. Okay, if you want to make 10, for instance, you have to bring 1 and 0 together. Okay, if you want to make 100, you bring 1 and you take 2 more zeros. That gives you 100. So for binary, you can only use 2 number system to represent it, 0 and 1. For denary, 10 options, 0 to 9. For hexadecimal, 0 to F, no G. For octa, 0 to 7. If you want to say base 4, base 4 will contain number from what? 0, 1, 2, and 3, excluding the 4. So if you are, suppose you are making up a number base called base 5, it has to consist of 0 to 4. Okay, 4, excluding 5. Okay, so but binary and hexadecimal are used by computers primarily. And this number, if you remember in your high school or middle school, this number 104 here is a denary number, base 10. When you say number is base 10, you see, that's the natural one. That's one. For instance, now This is 2022, right? So as a number, this is base 10. So you can write it as 2022 base 10, or just write 2022. Base 10 is like a default. It's a default base system. Okay? And I've told you how you can convert. Okay? So you have base 2. If you have number 101, and you want to convert this one back to, this is a binary number, right? You want to convert it to decimal number. Okay, you will start from the last number with 0. You write 0 on top of it, 1 and 2. Then you pick this one here, 1 times 2 raised to power 2. This 2 will always be your base. Remember, you're on base 2 system, and the power here is all the power you put up here. So this one is this 1 times 2 raised to power 2 plus 0 here times 2 raised to power 1 plus 1 times 2 raised to power 0. Okay, that's how to do that. For instance, if you have number 1011, you start from 0, 1, 2, 3. Then you want to convert this number to denary. This is a binary number, right? You want to convert it to what? Denary. Now, this is how you have to do it. Then you pick this one here, 1 times 2. You always have that base as 2. 2 raised to power 3 plus pick 0 here times again 2 raised to power 2 here plus pick 1 here times again 2. Always you have 2 all the time. 2 raised to power 1 plus pick the last one here, which is 1 here, times 2 raised to power 0. You see that? And you had it. This is going to be 8 plus 0 plus 2 plus 1. That's how to convert binary to denary system. So let me give you one more example. Okay, let's convert 100111101. Okay, this is 1. This is a binary number to what? To denary number. So what do you have to do? So you will write out this number 1001101. Then you start from the last one, right notes. You start labeling from 0, your index 0, 1, 2, 3, 4, 5, 6, 7. Then you start picking up all the digits one by one with your base 2 and raising them to each of the index up. So you have this 1 times the base raised to power 7. You will always have your base as 2 plus pick 0 here times the base raised to power 6, and so on and so forth. Okay, now look at when you are then you can convert numbers from denary to binary by dividing. So if you want to convert number 1, 2, 3, 4, 5 to binary, so like I told you in class, you pick that number 2 here and the number inside here. How many times does 2 goes in this number? You have this, leaving you a remainder of 1, and then you will move up that way, and that will give you that. Okay, so 1, 2, 3, 4, 5. Let me see the calculator, right? 1, 2, 3, 4, 5. Calculator. Okay, 1, 2, 3, 4, 5. Look at that. You see exactly the same thing here, right? But yeah. So it's now it it contains everything you have here, except that it's represented as, let me count how many digits you have here. 1, 2, 4, 5, 8. Yeah, it's represented as 2 words, like 2 bytes. Remember, a byte is 8 bits. So try to make it 2 bytes. So instead of using 14, is that 14? No. Yes, 14 digits. You count it 1, 2, 3, 4, 5. That's 14. You just added 2 zeros to the left side to make it 2 bytes, because you need a byte, multiple of bytes to represent information. Okay, so you must know how to do this. Okay, and you can also convert, if you are converting denary to base 8, just divide it by 8. For instance, give me a natural number, a denary number, like maybe 445. This is a base 10, right? And base 10 is just base 10. Now, if I ask to convert to what? Base 8. All you have to do, just put the 45 here and put 8 here. So how many times does 8 goes in 45? That will be 48, right? No. 7 times, no. 40, right? So 8 goes in 45, it goes in 5 times. Remaining what? Remaining 5. So 8 goes in 5, 0. Remaining this 5. So once this number is bigger than the one inside, so if you now say how many times does 8 goes in 5, it has to be 0. But your remainder has to be the 5, the small one inside here. And you can go up. So you can now say 45 in base 10 is equivalent to what? 55 in base 8. The least one here is called most significant bits, while this one is called least significant bits. So you have to start from top up when reading it. Again, look at the MSB, most significant bits, MSB. Okay, and you can convert to base 16. For instance, if you want to convert number 52 to base 16, all you have to do, pick the numbers 52, 16. Then how many times does 16 goes in 52? 48. Start 3 times. Remainder what? Is that 4? Yeah, I think 4. Now 16 cannot go in 3. So 16 in 3, how many times? That's 0. Then remainder the small one here, remainder 3. Then you read from bottom up. So 52 is now equals to 34 in base 16. Another way you can write base 16 is to write OX before the number, OX34. So those are the things you can do. You can convert. Now I've shown you this. You can convert a number from binary to decimal, or from decimal to binary. You can move numbers from any system. So you just have to follow the examples on these slides on how to do them. Look at this example, for instance. So you look at the power I told you about. You start from the smallest one here, 0 here, 1, 2, 3. You go, and that will give you all this. Okay. If you have 1, 1, 0, 0, 1, 1, 1, 0, 1, you count it. You start from 0, 1. You start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then you start picking all the number one by one. So 1 times 2 raised to power 9 plus 1 times 2 raised to power 8. You keep, see all this one here are the numbers here. But the base 2, the 2 will be the same. And the power will vary based on what you have here. Plus, this one times 2 raised to power 7. 0 here. Plus 0 times 2 raised to power 6 on top of it. And so on and so forth. So let me skip all that, and then so once again, the digit that you use to represent binary is just what? 0 and 1. What about octa? You use 0 and 0 to 7. What about decimal numbers? Denary, use 0 to 9. What about hexadecimal? Use 0 to F. These are the examples. Okay? And we also discuss ASCII code in class, which is an American standard code for information interchange. And I told you, don't forget, uppercase A is coded as 65, and lowercase a is 97. And that's a formula I gave you: lower code equals upper plus 32. That's the code for for representing uppercase and lowercase English alphabet. But ASCII code system is not the only one. You also have a Unicode, universal code. The Unicode covers more characters than ASCII code. The ASCII code does covers mainly English alphabet and some few other characters. Okay, look at all the characters here. Look at the question mark, dollar sign. The code for dollar sign is 36. The code for plus is 43. Now, the plus, when you press plus on the PC, imagine the code for it is what? 43. So the 43 is converted to what? Binary numbers. Then the computer understands that you are using the plus sign. So internally, everything that takes place is what? Zeros and ones. Okay? So you have more here. Look at all the other alphabets. Even numbers themselves. Number 9. The code for number 9 is 57. You can imagine everything is what? Is coded as numbers. I showed you in class today that images, you can code images as what? As numbers. Right? If you still remember, let me see if I can close this one up here. Look at the image. Now, I read this image here. If I want to display the image, I can say im show. You don't worry about this code, okay? I'm just showing you some program. This is what it's called computer program. Computer program. Now I can show the image on the screen, and the image will come up. Where are you? See the image? That's the image. This file is an image file on my system. Okay. Now, how does image look like in the memory? So, image 1 here is represented as numbers. I'm telling you, as numbers. Now, this is for me to see, but internally, it is actually zeros and ones. Okay, actually zeros and what? Zeros and ones. So that is that, and so ASCII code uses 8-bit coding scheme, and it defines only 128 characters, which map to numbers between 0 and 127. So you use numbers between 0 and 127 for coding. For coding in what? In ASCII character system. Again, the meaning of ASCII is what? American Standard Code for Information Interchange. You also have Unicode, which is more. It defines more characters, and the other ones. So data representation, you represent data to understand fully the way computer processes data. You should know how a computer represents data. We have talked about this. So most computers are what? Digital. They recognize only 2 states. I'm just repeating it over and over, which is on and off. So we use number 0, digit 0 to represent off, and we use 1 to represent on. Okay, so for instance, number 4 This is the number 4. Our number 4 is stored 00000110100. So let me bring up calculator and type number 4 now. See 0100. Is that 4 that is there? 8-bit for it. Okay, let me see. I made a mistake there. Let me 6. Oh, I see what happened. Here, I think 8-bit byte for the number 4. Oh yeah, so the original number 4, they just added more digit to make it 8. Okay, but generally if you want to represent the digit form of a number, if you want to do it manually, you have to do the way I taught you in class. Like you divide it, for instance, number 4. Let's find it bits for number 4. So how many times does 2 go in for? 2, remaining 0. How many times does 2 goes into? 1, remaining 0. How many times does 2 goes in 1? 0, right? Then remaining what? The 1 inside there. Then you go up. So it has to be 0. It has to be 1, 0, 0. But you have to add 5 more to it. Okay? I don't know what they actually did here, but this is how you represent number 4. And this is obvious from what you have here. You see? Okay, and so for letter E, English alphabet E, the code for E, A, B, C, D, E. A is 65, this is 66, 67, 68, 69. So denary number 69 is the code for E. Let's convert 69 to binary. 69. Look at what you have. You have 0100 0010, which is, I think, wait, is it the same? Really, I'm just flabbergasted. Letter E, 01. Yeah, okay, I think it's right. Yeah. There's something wrong with this text, but nevertheless, you should know that everything is stored as binary. So when you convert your 69 to binary, whatever you get is the actual binary code for E. This might be wrong. It might mean something else. Okay, so how is a letter converted to binary form and back? So when you press letter T on the keyboard, so the scan code for the capital letter T, maybe I don't know T, whatever number is for T, is sent to the system unit. Then the system unit converts the letter T to the ASCII binary form, which is this, and then goes into memory for representation. And then the CPU processes that and send the signal to the video graphic, and then display the letter T for you on the screen. So we are just receiving your call, pressing anything. What is going on internally is what? Bits manipulation. Bits manipulation. Okay? Yeah, once again, I told you in the olden days, in those times, we see mixes of analog. See, what they had then is what? Analog. And analog travels in this form, like a waves. But all our phones, iPads, we call them digital equipment. This is the way signals are represented in them. Okay, so to convert from analog to digital or digital to analog, you need what is called modem. Okay, which is an acronym or a word for modulator, demodulator. Okay, I've told you earlier on, so I don't have to go. So modem is derived from modulator and demodulator. Modem. It's an equipment. You have it at home. If you have internet service at home, you have a modem at home. Okay? So a bit, binary digit can either be what? 0 or 1. So a byte is a what? Combination of 8 bits. 1 kilobyte is 2 raised to power 10 bytes. The meaning of ASCII is what? American Standard Code for Information Interchange. So A, uppercase A, is coded as this. Number 3 is coded as this. Okay? And once again, ASCII uses what? 128 characters to code anything. So which is number 0 to what? 127. So 65 for uppercase A, 65, 66 for uppercase B. Other numbers between 0 and 127 represent other characters like your hash, your question mark, your dollar sign, and all the stuffs. So then the memory sizes again. Now most laptops are gigabyte, but I mean we are having terabyte, 2 terabyte laptops. So that means we are having more memories, and they are all expressed in terms of what? The power of 2. Kilobyte is 2 raised to power 10. Is 1 kilobyte. You have 2 raised to power 20, 2 raised to power 30, 2 raised to power 40, 2 raised to power 50. That is no 2 raised to power 35. Okay, so just the difference in the power is 10. This is kilobyte. This is megabyte. This is a gigabyte. This kilobyte, megabyte, gigabyte, terabyte, petabyte. You see, you remember petabyte? 50. Pentagon has 5 sides. Okay, petabyte. And yeah, you have it more here. See, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, zettabyte, exabyte, zettabyte, and yottabyte. So look at petabyte here. Look at petabyte here, 2 raised to power 10 TB, which is a 2 raised to power 40, 50. So now this, most of the YouTube, all this cloud storage, they have multiples of yottabytes, zettabytes, exabyte, and petabyte to store people's videos. Twitter videos, YouTube, Facebook, they have a backup servers. They have a storage devices that can store people's photos, images, and anything, sound, audios. So software programs that do something. I've talked about application software and system software. So operating system like your Mac OS, all this are your OS, but all these ones here, they are application programs like your web browser, your Skype, Google Drive, App Store, the game, web browser, word processors. All these are application programs. Yes, we've seen internal storage, which is when using a computer, the most common storage medium is the internal hard drive. I showed you hard drive today, which consists of what? Magnetic disk, and it can move. And we also talk about SSD, solid state device, which most of your mobile electronic devices use. Your laptop, your iPads, they use SSD. But your desktop case, PC, uses what? Magnetic storage medium, which is fine. Both of them store something. I will discuss in class today that SSD is more durable, and you can expand it. You can, it's mobile. It's more durable. It doesn't use a magnetic. It doesn't use a moving parts. Okay. So internal hard drives are installed in the computer you are using. So like the second video you are watching, you can install your hard drive by yourself. Okay. And you also have external hard drive. External hard drive, I think I've got one here. One moment. So this is the one I have here. This is I have an external hard drive here. You see that? And this one is I think it's 2 terabytes. 2 terabytes. I have information there, and I can't share this with anybody. Okay, so in case I lose many information or my system becomes damaged, I can still have a backup here. So it's always very good to have a backup. So that's external hard drive. Then you have a cloud storage. Now, if you don't want to store anything on your PC, you want to preserve the space, okay, you can actually put everything in the cloud. The cloud doesn't mean you are storing them in the atmosphere. No, the location, it's actually a physical machine that is somewhere far away from you, like your Google Drive, MS OneDrive, Dropbox, all this. For instance, cloud storage enables you to store your files remotely on its servers, on a machine. Servers are machines, okay, that could be in a different city, state, or any part of the world. Storing files from a cloud, right, requires what? Your device and internet connection. So if you have cloud storage only, then you must have internet access. Without internet, of course, you cannot access the cloud machine. So look at the cloud. Now, they put this in the cloud. Does not mean this machine is in the cloud. It doesn't mean it's in the cloud. No, it might be in a, for instance, it might be in California, okay, in a big industry. And then look at it, it's very, very big. The servers are really, really very big. They have more memories. You don't have to physically put your information here. You can process a lot of information from here and here. But you must have internet. And in the era of data science or big data analytics, most of your mechanisms can be on what? On the cloud, because physically you don't have the capacity to store big information. Okay. When you want to buy your computers, these are the following factors you must consider. The platform. Do I need to use software that requires a specific platform? Does the computer need to be compatible with other devices? So you have to consider hardware. Do I require specific hardware for game and other stuff? Then you have to consider the specification of the hardware, the form factors. Like the form factors actually mean like for instance, if you are in a plane, if you are going on a plane, iPad is better, right? You cannot carry this machine that is as big as this in a plane. That's not possible. So if you are a traveler, if you travel a lot, you just need a mobile device. Okay? Will you need additional devices to perform additional tasks? You might have to consider whether your PC has got some expansion ports at the back for the additional devices that you might need. You might be playing game. You might need dedicated devices to be added to your PC for more functionalities. So you have to consider that when buying your PC. So once again, what do you consider when buying PC? You consider the platform, the hardware itself, the hardware specifications, form factors, and add-on devices. Okay. And then you also consider different processor requirements, different memory requirement, different storage requirement, and other stuffs. Then we see that printers, like we saw in class today, you can have inkjet printers, laser printers, multifunction devices printer, mobile printer, plotter, 3D printer. We have 3D printer, of course, in our system here. Okay, you can print stuff, and I think I can really show you really quick the 3D printer, but I won't talk because I'm going out of my office now. Okay. So this as you can see here, this is our 3D printer. We have it. So you see, look at it. You can print stuff like this. You can print stuff like this with this printer, right? You can print this. So I can, maybe someday I can come and show you if you have not seen it before, right? So So these are the types of printers you have, and I think finally today you need this. You need the following steps to keep your computer clean, or how to maintain your computers. Make sure you keep the keyboard, the mouse, and make them clean. Gently clean your monitor all the time. Keep food and beverages away from your desktops and laptops. Organize the cores and other e-debris properly. Don't overcharge your batteries. Don't block the vents for ventilation. Have a decent desiccant on hand to clean it. Keep magnet away from your device. Be careful with unfamiliar Wi-Fi network, especially in the at the airport. Get a phone case and screen protector. So these are the general ways through which you can protect your PC. And this is where I'm going to end this video today. And I hope this has been very informative for you.